Hey guys, so we're continuing on to the notes for 4.1, the part 2 notes. And these are some more things that you're going to see in ALEKS. So what you're going to be asked is whether you're going to have to be asked to determine whether these statements are true or false. And what you're going to use is this diagram that we give you. So remember, this is a Venn diagram, okay? And it shows how the figures are related to one another. So the bigger circle, the bigger the circle, the more things that are in it. So just a reminder of what a Venn diagram actually is. So when you look at this Venn diagram, everything inside it is a quadrilateral because that's the biggest circle. And then everything inside the blue would be a parallelogram. Everything inside the red circle would be a rectangle. Everything inside the green circle would be a rhombus, and everything that is pink would be squares, okay? So when you use this, we're going to use this to determine whether a statement is true or false. So look at the first statement. The first statement says, every square is a parallelogram. Well, if I find squares, I can see that squares are inside the blue parallelogram circle, so that I know that this is a true statement. The second one says every quadrilateral is a rectangle. So if I look at my picture of the Venn diagram and I look at all the quadrilaterals, which makes up the entire circle, are they all rectangles? No, they are not. So this is a false statement. In the next one, it says every rhombus is a parallelogram. Again, if I look at the rhombus in my Venn diagram, does it indeed fall under the parallelograms, under the blue? Yes, it is inside the blue, so therefore this is a true statement. And the last one, every rhombus with 4 right angles is a square. If I look at my little green circle of rhombus, if I make a rhombus at 4 right angles, does it indeed become a square? Yes, it does. So this is another true statement. Okay. So in this next one, we have to think about all of the properties of each of these quadrilateral figures in order to be able to answer the statements or the problems or examples that you're going to have in ALEKS. So let's talk about each of these quadrilaterals. Each of the quadrilaterals that are listed in the first row have diagonals that bisect each other, okay? So a parallelogram has diagonals that bisect each other, okay? A rectangle has diagonals that will bisect each other, which remember bisect just means touch or intersect. A rhombus has diagonals that will bisect each other, and a square has diagonals that will bisect each other, okay? And the next statement says, these figures have diagonals that are congruent, which remember, congruent means that they are equal, okay? Another sign for congruent is the congruent symbol that we've been using. So diagonals that are congruent, you would see a marking like this. You would see that a rectangle has diagonals that are congruent. So you'd see 2 rectangles and you'd see that all of the diagonals are congruent. You would see tick marks just like that. And same with a square. So a square has diagonals that are congruent as well. So you would see tick marks on each of the pieces of the diagonals. Okay. And then look at the next feature. The next feature says these particular quadrilaterals have diagonals that are perpendicular, which remember, perpendicular means that they form right angles, right? So they should have a right angle marking. So if I look to make those markings in here, a rhombus has diagonals that are perpendicular. So if you draw the diagonals in from across to each side, you will find that there is a little square representing the perpendicular sign. And then same with a square. A square has diagonals that are also perpendicular. And again, you will see a little square on the inside to indicate the 90-degree angle. And the last feature that we're going to talk about is that these particular quadrilaterals have diagonals that bisect angles, okay? Which means that they have diagonals that cut the angles into equal parts. So bisecting angles is cutting it into equal parts. So it would look something like this. where you have two angles and they have two markings to show that they got bisected into two equal parts. So if I draw that here, a rhombus has diagonals that bisect angles, which means that this angle is equal to this angle, and this angle is equal to this angle, and this angle is equal to this angle, right? It's cutting the angles in half, or into two equal parts. And same with a square. So a square has diagonals that bisect the angles. So if I draw the angles in, again, this one's equal to this one's equal to this one. It cuts the angles in half. Okay, so these are all the features that you need to know about or use your notes about in order to solve the things in ALEKS. And then there are two more things to know. If one pair of sides of a quadrilateral are both parallel and congruent, then it is a parallelogram. So this is another important piece of information here. If they are parallel and congruent, so if you see a quadrilateral that has markings where one pair of sides has a congruent marking and it has a parallel marking, which we use with the arrow, then that is a parallelogram. That is indeed a parallelogram, because they're going to ask you whether something's a parallelogram or not. And then if alternate interior angles, another fact for you, if alternate interior angles are equal, then you have parallel sides, which means you also have a parallelogram. So for example, if you have a picture where the alternate interior angles, so the interior angles on the opposite sides here, are congruent, like this, where the opposite angles are congruent, then you know that you have a parallelogram, because it is telling you, because that tells you that this one must be parallel with this, and that this side must be parallel with this side, okay? So when you have those angle markings, that does tell you that this is also a picture of a parallelogram. So now what we're going to do is we're going to use all of that information to answer these types of questions that we will see in ALEKS, okay? So in example number 4, we're going to select all that apply for each figure, okay? So first of all, in order for something to be a quadrilateral, it just has to be 4 sides. So right off the back, I can say that all of these are quadrilaterals because they all have 4 sides, okay? Then there's the determining whether something is a parallelogram or not. Again, using the information that we just had, if it shows that opposite angles are congruent, just like this one shows in the first example, then this must be a parallelogram. In the second picture, again, in order for something to be a parallelogram, the diagonals have to bisect. So this is also a parallelogram because it has those symbols showing that the diagonals bisect each other. Okay, or cut them into, or they're all congruent. And then the next one, if we look at the last one, all of the angles are congruent, which also must mean that it is a parallelogram because still the opposite angles are equal. So all 3 of these are parallelograms. Then we have to determine whether it is a rectangle or not. And again, if you use your notes from the last page, a rectangle, remember, has diagonals that bisect each other or that cut them into congruent parts, diagonals that are congruent, and a rectangle has 90-degree angles in the corners. So the first one shows no indication of 90-degree angles or diagonals, so this one is not a rectangle. Okay, so that one is just the quadrilateral and parallelogram. If you look at our second example, that one does have angles, diagonals that are cut into congruent parts. So that tells me that this must also be a rectangle, okay, because it was cut into congruent parts. And in the third, what this tells me, or what these pieces of information tell me, is that all angles are equal in measure. Well, all angles in a quadrilateral add up to be 360 degrees. And if I take 360 degrees and divide it by 4 to get 4 equal angles, then that tells me that every single angle is 90 degrees. So I could mark these with squares. And the feature of a rectangle is that all four angles are 90 degrees. So is this a rectangle? Yes, it is. This is a picture of a rectangle as well because all of the four corners are 90 degrees. Okay. And then you're going to be given a picture of quadrilaterals and determine whether they are a parallelogram or not. So now only two options. So again, remember a parallelogram has to have diagonals that are congruent or that bisect each other. So if you look at the first one, the markings that show on this first one do not show the diagonals bisecting each other because they're not in the right spots. The diagonals are not getting cut in half. Therefore, this one is not a parallelogram. In the second one, if you look at the markings that they give us in the second picture, they give us that these two sides are are congruent and they are parallel. And if a side has congruent, if one pair of sides is congruent and parallel, then that is indeed also a parallelogram. Then, if you look at your next picture, notice that we have a couple markings here. We have that these two sides are parallel. We also have that these two angles are congruent. But remember, when you have an angle that are congruent, the side across from it is also congruent. So now I have similar markings to the last one, which I determined was a parallelogram. So this one too is a parallelogram. And then the last one, if you look at the markings we have opposite angles are congruent based on those markings. And again, that is another thing that tells me that this is a parallelogram. When the angles opposite one another are congruent, the alternate interior angles, then it is a parallelogram as well. Okay? So take your time with this and use your notes because this is a little bit tricky when it comes to all the features of a parallelogram and a rectangle. Okay? And as always, let me know if you have any questions. Good luck.